I see my old friend Jackson Andrew on the call here.
Hello. I'm
Hello.
finally able to make these things now. It's great.
Yeah. Yeah, Jackson and I go back a ways. For those of you who uh, don't know, I am here in the College of Engineering at Virginia Tech. I have a couple different roles. Among those is leading our Pathways for Future Engineers program, which is a pre-college program working with high school students, particularly first generation high school students. Secondly, I lead our Digerati Living Learning community. And so, certainly part of this opportunity to lead our Maker Mondays program is to give you a glimpse of life at Virginia Tech. You can see some folks on the screen right now who are current Tech students. We are just in our second week of classes here at Tech, so they look remarkably unstressed right now. Uh, that will change in April, but for first week, we're looking pretty good. So I do have with me here some folks from our wind turbine team here at Virginia Tech who are joining with us and who are part of this journey. Um, Again, bear with me as I'm letting folks into the meeting. I see we're at about 30 participants right now. So I'll give it maybe one more minute before we get started so we don't have to repeat too much. Um, these Zoom calls happen same channel, same time every week. They will go through our competition here at Virginia Tech, which is March 19th, I believe. Um, and so, if you've been part of our previous phone calls, what Maker Mondays is a build session online for everyone. Our interest is in encouraging your creativity and problem solving abilities. Our goal with this spring is to build a wind turbine. We are working in conjunction with the Kid Wind competition being held in Virginia, which is a program collaborative with James Madison University and their CASE Center. Our goal is to, with these sessions, is to share some ideas. We will have throughout this spring some different guest speakers talk about different approaches to wind power, both at a broader scale, but also at a micro scale. And certainly part of what we're doing is as you're building these wind turbines is to look at your creations, give you ideas, maybe point you in the right direction on how you could look at your own creation. A couple of housekeeping notes, and I'll get started here in just about a minute. We have shipped out boxes late last week. They look like this. They're coming via the US Postal Service. They have parts in it that are recommended by the Kid Win competition as a starter kit. Tonight's call is really talking about what's in this kit, how it works, and how you can begin what you're doing. Um, Certainly, as you have any questions of anything in your kit, do let us know. A couple things that I put in the email. We one of our packages that we received with supplies was torn open, and so we lost some resistors in the mail and realized we don't have enough. So I'm going to be shipping those out to those that did not get them. Um, know that most boxes probably are missing a resistor, which is included in the pack. We'll talk about that more in a little bit. Secondly, we have shipped this to everyone who gave us an address. We to try to be sure we had enough supply for everyone. We did one per household, but if you need more kits, let me know by email, and you can send that to pathways at vt.edu. Gets me, and I'm putting that in the chat. And I will be glad to send you more supplies out. We have exhausted all of our kits right now, but we are looking to order more. Okay, it looks like the movement into the meeting has slowed down, so I think we'll go ahead and get started. what we're going to do, and to my members of the Virginia Tech wind turbine team, I would ask you if you would just to introduce yourselves. I know we did this last time, but I'm sure we have some new folks on the call. If you would introduce yourself. After that, I want to share a video done by JMU's Case Center, which goes over what's in the box. We'll show that video, which is available on YouTube, by the way. And then what we'll do after that is go into a little more question and Q&A on the supplies and the kits with our wind turbine team. My assumption is that many of you, as we're getting these kits in the mail, the next thing is, what do I do with this? How do I begin? And so we'll talk about that a little bit to wrap up. We may not go the entire hour. One of the standard practices of Maker Mondays is I try to adhere to a 1 hour time limit, recognizing that many of you may have homework, and that's always a good thing to be focused on. So I want to be sure that we give you enough time for that. So starting out, if I could have my wind turbine team members introduce yourself. I'll start with Quinn. On my screen, I see Quinn close by, so I'll go that way. And introduce yourself and what you're studying at Tech. And then after that, once we get through everyone, I'll go into a brief video, and then we'll go into more of a conversation. So Quinn?
Yep. So hello, everybody. My name is Quinn. I'm an aerospace engineering student at Tech. I'm also on the aerodynamics sub-team within the wind turbine team.
Sean?
Hi, I'm Sean. I'm a junior in civil engineering, and I'm currently co-leading this project with Jaden.
Okay. Jackson?
Hello, my name is Jackson. I'm a junior in electrical engineering, and I am the power systems and control sub team lead.
Okay. And I see Jaden.
Hi, I'm Jaden. I'm a senior in mechanical engineering, and I'm the co-lead with Sean.
Okay. And do I have any others that I missed on the team?
That's all we have for.
That's what I thought. I was just double checking. Okay. So what I'm going to do, first thing I want to start with is an introductory video. So if you'll bear with me, I'm going to share my screen into a video done by JMU's Case Center. And this gives you an overview. This is done by Remy Pangle, and gives you an overview of what is in the box. So bear with me. This is about a 10-minute video. We'll go through it very quickly.
Hi, this is Remy again from Case at JMU. And in this video, we are going to unpack your kit that you received to start prepping your team for a KidWin Challenge. So this is the default kit that people are going to receive. This one does not have the PVC turbine in it, nor does it have any blade materials in it. So we're not going to unpack this one in particular, but just know that it's the same as this, except you won't have the PVC or the blade materials in it. Let's talk about what's in the kit. So when you receive your starter kit, you're going to have a multimeter with some alligator clips. And this is so that you can measure the output from your generator. So this is the key for the wind competition, is the KidWin generator. In order to be able to harness energy from the wind using this generator, you need to be able to attach the hub to the generator and then blades to the hub. And so that's what the dowels are for. So the dowels in the hub are going to allow you to catch that kinetic energy in the wind, transfer it to the wind turbine or the generator, and then
Perry, I don't think we hear it anymore.
Audio isn't really transferring. Mr. Martin, you're muted.
All right. Then you're going to have 4 elbows and 4 T's. And then all of this is going to come together and it's going to be fabulous. All right, you ready? So the first thing I would do is construct the base. And so for the base, you're going to insert 2 6-inch pieces into each of the 3 of the T's. Okay, so now this is going to get turned into an H. So you've got your 2 pieces on one side, and then one is going to stick up in the middle. And that's where your tower is going to go. You can finish it there if you want, but I like to add the elbows as feet for my tower. It also helps it to be a little bit stable. There we go. Okay. And that leaves the last piece, which is what we will call the nacelle. So this is where we're going to insert the generator. So you've got your coupler with your small little PVC piece attached to an elbow. Okay. And then that is going to pop onto the top of your tower. So there you have your PVC tower. The next thing you have to do is you have to install the generator. Okay. So these are the Kidwin generators. There's, if you buy like one of the kits from Vernier, you're going to get 2 different generators. The other one's going to be a little bit skinnier and a little bit longer. And that is a high torque generator that puts you in the open division. Don't use that. If you're starting out, make sure you're using the Kidwin, the fat and thin kind of generator. So the first thing you'll do is you're going to run the wires straight through. So you want the generator to sit right here. You're going to drop the wires in, and they're going to go all the way through to the back. Okay, fantastic. And now you can hook it to the generator and measure the output. But the key here, the one last thing you want to do is this thing is really loose in there. So if you have some electrical tape, you can use pretty much any tape you want. If you wrap it a couple of times around that generator, it is going to give it a little bit more diameter, and it's going to stick better into that PVC coupler. You may have to do it a couple of different times to get it to fit, but it's going to fit a little bit more snug. So that way, every time you take the blades on and off, it doesn't pop out. Okay, so this is the basic setup. The next thing that we are going to need to do is we need to build some blades to put onto the wind turbine. All right, so this is your hub. This is what we call a 12-hole crimping hub. It's a little bit confusing to use, but I'll walk you through it. So you're just going to untwist it a couple of twists, and then it should pop open. So there's just a little bit of a crack. Once you have it popped open, you're able to stick your wooden dowels in. Okay. If you need to unscrew it a little bit more to get some more room in there, you're going to hear them kind of click into place because there are grooves in there. And then you're going to tighten it up, just finger tight. They're not going to come out. They're not going to fly out. And at this point, the little hole on the very back is going to match up to the shaft on the generator, and you're going to be able to pop it onto your turbine. And so when this turns, you're going to hot glue blade designs onto these dowels. And like I said, some of you will have blade materials. Otherwise, I highly recommend some, old Amazon boxes, old poster boards, anything you can find in the recycling is perfect for blades. And at the competition, remember that they do give you points based on innovation and selection of materials. So recycled materials, you get a couple extra points there. But you can hot glue those right onto these dowels. And then when they catch the wind, the generator will spin and we'll be able to measure the output using this multimeter. Okay. And I'll show you real quick how we can measure the output using your multimeter. And then I think you'll have everything you need to be well on your way to making your own turbine and having your kids start experimenting with lots of different blade designs. All right, so when you set up your multimeter, the black lead is going to go in the bottom hole. And then the red lead is going to go right above it in the second hole. Okay, make sure you push them down so they're nice and tight in there. You're going to connect your red lead from the multimeter to the red wire coming out of your generator using the alligator clips in your kit. They're not always going to be red and black alligator clips, so just as long as you connect red to red and black to black, doesn't matter which color the alligator clip is. And make sure you're connecting it to the metal on your generator and not the plastic. Okay. And then we're going to set this. These are direct current generators. So where you need to use the V with the line and the dotted line that represents direct current. And then we're going to set the multimeter to 20. And when you spin the generator, and again, if you had blades on here and had it in front of a fan, it would do this on its own. And it probably would fall off like that. And the last thing that I'll show you is how you can use this pitch protractor to make sure that the angle of your blades is consistent. Okay, so you're going to take your hub off of the generator and hold it in the palm of your hand with the dot facing down, the hole facing down, and the screw part facing up. So if you had a blade on here, you would take the pitch protractor, and on the back there's this little groove, and it allows it to set right on the hub just like that, and it's perfectly level with the hub now. And you can use that, and you'll just look down. If you had a blade on here, the blade would tell you what angle it's set at, and you can adjust them. If you just untighten the screw just a tad, you can just move your dowels a tad so that you can get it to the angle that you want. And then you just lift it up and change to the next blade. And now you can just make sure all of your blades are at the same consistent angle. And of course, you can do experiments on different pitch angles to figure out what's the optimal blade angle. But it's a real important tool to have, and hopefully it is a helpful piece of your kit. If you have questions about how to go further, you can contact me at casejmu@gmail.com or look for more videos on how we'll advance with a gearbox added to the turbine and other advancements that you can look into.
Okay, so that was Remy Pangle from the JMU's Case Center. Remy is primarily the point person for the Kid Win competition. That's not something that we run at Virginia Tech. Our role, again, is to give you advice or help as you put your challenges together. The other thing I'll note that you can, while we have a regional competition here at Virginia Tech, you're certainly welcome to enter any of the competitions you want to. And you can also participate without entering a competition. That's perfectly fine too. I'm going to go ahead and get to a couple of questions. We had a question about the PVC pipes. We don't provide PVC pipes. We rely on you all to come up with your base. And I'm going to ask my turbine team for a little help, and I'm actually may get an answer from Remy on this. Normally in these competitions, is everything done in the Kid Win by PVC, or are there other materials, do you know, that they can use for their mount and base for their turbine? Or do we have an answer for that from our tech wind turbine team?
Read the question again? Sorry, I don't think I understood it
Um,
exactly.
Now, the main question I have is on the PVC base, do you know in the competitions if they have to use PVC or if they can use other materials?
I'm not sure what they've done in the past.
Yeah, I may have to send an answer on that from Remy. We're not shipping out the PVC pipes. They're again, it's something that hopefully you'll be able to find to get your own design for how to mount it. But again, we send out a kit with some of the more technical things that's needed. Another question I have that again, I'm hoping we can get a little more of an electrical explanation for related to the resistors. But in the video, she didn't talk about the 30 ohm resistors. That was part of my list to send out to my competition team. What would the resistor be used for?
So I guess the best way I like to think about it is when you're powering something with a wind turbine, it's the same thing as you would power something with a bike. So if you're pushing really hard with the wind turbine, right, with your bike, you need some amount of resistance so you actually like use that power. If that makes sense. So what the wind turbine does is it gives you an opportunity to access power. The resistor is turning that access of power into electrical power. That makes sense.
Okay. So where would they hook in on the design that Remy just showed? Would that go in from
So there should be two leads on the bottom back of your DC motor. There'll be little holes in them. When you actually see it, it'll be like little brick, and then like two leads on the back here and here. And if you like put a wire across those two leads and a resistor across those leads, you should be able to produce electrical power.
Okay, so I'm pulling up here, and Jackson, see the two leads right here. So this is your motor here. You're seeing your two leads. So you're saying you would cross the two?
Yes, you won't want to like I don't know if you have alligator clips in there, but you can like put alligator clips to hold the resistor to the leads and the multimeter as well. You can then measure the amount of power you're producing across that resistor with the multimeter as well.
Okay.
I
Okay.
can put a design, like a little like Visio picture if you want. Maybe that'll be easier to understand.
Yeah, I've got you on you can share screen.
Oh, okay. I guess I can try.
Okay.
Here, hold on.
And
So
I
that
do have a question there if you all want to check the chat real quick.
I don't know if I need to share my screen, but I have a couple breadboards here I can just show.
Okay.
So we can use a breadboard as well. Sorry, let me unplug my back. So we can use a breadboard as well. So I have a resistor around here. There we go. So if we put a resistor in our breadboard, and this should, I don't know if we want to give them breadboards, but I think we can just like use alligator clips. But one thing we can do for if you really want to like, I think personally we should just use alligator clips and just put them all on one thing.
Mhm.
Do you have alligator clips? Yeah.
Yes.
So,
Every kit has alligator clips.
yeah. So just put an alligator clip in a resistor, in the resistor in the same alligator clip, I guess, as the one of the leads, and another alligator clip on the other side of the lead. I would just use the alligator clips as like holders, other than like actually connecting anything with them. I don't have any alligator clips with me right now, but
Yeah, and you can see here in the kit, you'll have what you receive, and you'll have this many alligator clips there for you. We do have a resistor question in the chat.
I see your EBAD. I think I'm saying that right. Yeah. You can do that in series. That would just be like putting like using alligator clips to put it in between two more resistors. Or what you can also try is putting just a 10 ohm resistor or putting two 10 ohms in parallel. I don't know if you've ever tried doing that. That's would be like instead of like putting one resistor in the alligator clip, you can put two resistors in the same alligator clip. That would create you a 5 ohm resistor. So that way you can like see which one produces makes your wind turbine spin faster or produces the most voltage across it. Because it will change. It should change based off of which one, which how much resistance you use. Yeah, you certainly can. I don't know if you can use circuit boards. You need probably a soldering iron for that, but I would recommend just buying your own. Perry, I can also send you a good way to get a ton of resistors.
Okay, yeah, that would be helpful. And if you're watching the chat, you can see the answers or see the questions. We had a question related to using 10 ohm resistors and how they could be wired up, and then salvaging resistors off of dead circuit boards. Colin has a question. So you put the resistor between the two clips holding the two wires. And that's.
I wish I had something. I guess, yeah. So Perry, if you have a wire, yeah, try putting a wire on an alligator clip. I'll show you what I mean, hopefully. Do you have any resistors with you right now, Perry?
I have one.
Okay. So connect one end of the resistor put it on there and put one end of the resistor as well on that same clip.
Okay. So I need to get my resistor. Let's see. And if you haven't seen the resistors, they're rather small. They're easy to lose, but this is what I've got right here. So as a demonstration, we've got a wire right here. And then coach me through this, Jackson.
Yeah, so on the same lead where you put your wire with the just put it on one of the ends and put on that same alligator clip with the resistor, put one of the ends of your generator.
Put one of the ends of the generator. Okay. So I've got the generator right here, and I've got the resistor on the same alligator clip. And then what?
Yep. And then take another and do the same thing with another alligator clip on the other end of the resistor.
On the other end of the resistor.
Yep.
And you have to have good dexterity to do this, which is not one of my strong suits. Because these are small parts. Okay. So what we're seeing right here, does that look, albeit messy, like the right concept, Jackson?
Yep, that's exactly it. And I guess to answer Ebad's question, yes. So Ebad, if you wanted to make a 5 ohm resistor, you would put two of your 10 ohms resistors in the same formation. Instead of using one resistor, you put two of them in there. And that would like two resistors in parallel will have each other out. They'll like do one half of the actual resistance. They're the same.
Okay. Other questions related to the process of building. And again, you can put those in chat. Yeah, is there a YouTube link for the video earlier? I'm going to put that in the chat, so do bear with me. And I will also send this out after the meeting so that you have it as well, but I'll go ahead and put in the chat. We have a question. What was the gearbox she was talking about at the end? Some of these questions I may need to get back to you on some of those because they relate directly to the competition. One of the aspects of, and I'll jump to Henry's question on the material restrictions. you can try different materials for your fans, for your blades, excuse me, that you're doing. So there are in the competition points for using recycled materials, etc. So you can experiment with different materials that you want to put on there. The gearbox specifically, the only thing, um, are you referring to this piece right here? No, okay. So you're talking about a different thing. I'll have to get back to you on the gearbox. It's not part of the materials that we have. I guess a question I would ask you all on the VT team is in your all's competition, do you all do tinker with gears or things in some respects to increase the output, or is that something that's not part of normal design?
We don't do any gearbox issue changes with our design. I think I would probably ask Henry. I think Henry would know better, or Jaden. I don't know if you know this, but I don't think we've ever used a gearbox to like maximize speed. I don't know if that would increase the amount of power or not. I really don't. Wish I did, but
Yeah, I can get back to you on that question about clarifying what you meant by the gearbox, and we'll send that out. And again, just know these meetings are things where we can continue to ask questions. So if I don't have an answer to them, we certainly will have those for the future meetings. Colin has a question on where the second alligator clip connects. And I see, Colin, you're on screen. So are you working on clipping yours right now? So I think that second alligator clip, what you're referring to, um, you keep in mind you're looking at both your leads on your motor, but then you're also going to have a way of measuring the output from what's there. So just keep that in mind that that's part of why we use the alligator clips. So Colin, you're talking, you don't have the resistors, you're just clarifying. So again, going back to the model here, you're taking your motor, that your generator, excuse me, that you have, and you're going to be connecting both leads of that, and then you're putting your resistor also in that same clip, connecting both of them. Niam, I see your question. It only has a square thing on one end, and I'll speak to my engineers on the call here. This is what our resistor looks like. You can see there is square thing on each end. Could somebody kind of explain what they're looking at here when they see this? Let's see, Quinn, I can't, are you on?
Oh,
There
yeah,
you
I
go.
guess I can answer that one. Yeah, so the square thing isn't really that important. It's really just there to protect the wire. Um, so you're using the alligator clip to just connect the two wires together, and that's really the important part. Just make sure that when you are using the alligator clips, that the other ends of the alligator wires are not touching. Just be sure of that. But yeah, the square things really don't matter. Assuming that's what you're looking at. Yeah,
I think those square things might just be a packaging thing.
yeah, that's what I was thinking. So
Is there a bunch of resistors? Because if there's a bunch of resistors, they sometimes come in like cut and reel, and that's what those a lot of square things are.
Yeah, that
Sorry,
could be it. That could be it, Jackson, because I don't have the packaging with me. It was kind of interesting. The package we got was tore open, and the quantity we had ordered was not there. So our assumption is that they fell out. This was the only pack we had, and that may well be from what separated from it. So, because I was thrown by it a little bit too when I got it out. I didn't actually unpack these. I'm seeing a couple questions directly to me about making metal blades from recycled metal. Um, Certainly would defer to the competition on this. My understanding is as long as things are done safely, that you can experiment with different materials. And certainly the question about bending and maximizing the pitch, the what we'll call the protractor here that you have, really is about giving you a chance to look at what angles you want on your blades and having some consistency. So again, to answer the question that was sent to me, by all means, yes, you're adjusting, you're bending your blades in such a way to kind of see what works best at generating. We do see some questions in the chat on the multimeter.
I can answer questions about the multimeter. I kind of answered your question. Yes, you can use it to measure the current, but I think the best way to do it would probably be to measure the voltage across it. So the same way we put the alligator clips across the resistor, we can also put you also can put the multimeter leads in that same little like generator resistor and a multimeter as well, and then we can measure the voltage across the resistor. When we do that, we can then use the equation P is equal to V squared over the resistance, or voltage squared over the resistance, and that will give us the amount of power produced. So I think we typically get our wind turbine usually gets like 22 watts out to like 30 watts. So I think that's a good idea. I think this one would probably get around, I want to say like 6 to 10 watts, I think. Hopefully, I wouldn't know exactly. But another reason why I wanted to change the resistors, EVAD, is that you can see by using the equation like B squared over R, if you change it to a small resistance, you might be able to get more power out.
Let's see. And you do see some conversations about using um, um, the multimeter, which is this right here. One question I'll have of the team in general, and we have folks that are obviously tinkering with getting started on this. From your all's opinion, beginning this project, what would you begin with in terms of building? What do you see as the first step? They've gotten these things in the mail in the box. There's also materials that they need to create themselves. What do you see as the first thing they should do?
yep, I guess I can answer this one. So personally, the way that we do things as a team as well, we like to do a lot of research before we do any sort of construction. That way we could just save some resources and then just have a plan going into construction. So what that could look like for you guys, get like maybe a sketch of what your base is going to look like, and then plan out what pieces you're going to use. And then when you're finally ready to construct everything, you can just do it right from your sketch. For blades, since I'm more of a blades guy myself, you could be researching different airfoils, for example. You guys can use airfoils, or if you choose not to do that, researching kind of the good number of blades to use. You guys, I don't believe, are constrained to a certain number of blades, and so experimenting with how many blades to use and things of that nature. So definitely research before you do any sort of construction, just to save time and your resources. And then when you're finally ready, you have basically a plan to do everything you need to do. And Jackson, if you want to add to that, go for it.
You summed it up pretty well. That's what I would say. I think in my case, I don't really build anything as part of the wind turbine team anyway. So glad you answered that for me.
I do have an answer. We had a question earlier about the tower and the PVC. First off, normally the PVC is not provided to teams there. You do not have to use PVC for building your tower. If you do want to use it, the KidWin competition or JMU's Case Center can provide you kind of a sheet of the cuts and measurements you would use for doing this. But certainly you're able to fashion your own. You saw in the demonstration how the tower was created using PVC. Just know that you can use anything you want to, including obviously the PVC. And if you want the measurements or a cut sheet for that, that can be provided. Do we have other questions? And I appreciate the responses in the chat. Certainly, we welcome you to do that. We understand this is a learning opportunity, obviously for myself included. My background's not in electrical engineering. So, and I will give you a true thing as we're getting some comments, but these things that we're seeing are concepts that we're going to be using in so many different applications. This past weekend, as you know, it's very cold. The blower fan on my furnace went out, which is a very inopportune time when it's 8 degrees for your fan on your furnace to go out. I had a bad capacitor. And so one of the things that I did today was to go buy me a capacitor. I will be plugging in my leads when I get home tonight to try to get my blower fan going. Again, I'm not an electrical engineer, but I understand the significance of hooking in to positives and negatives, and the general concept of how some of these systems work. In the case of my capacitor, furnaces got too hot and it messed up my capacitor. And so suddenly I did not have a fan on my stove when I most needed it. So that's what I'm working on. So these are great opportunities to learn some of these current concepts of current and electricity through this competition. And if you have other questions, do continue to put those in the chat. Let me give a little bit of a glimpse while we're doing some of these questions here as to the upcoming events. So we do have every Monday night at 7, we will be having these discussions. As you work on your ideas, you're welcome to trade questions, concepts. Certainly we understand this is a competition and but our goal is to help everyone learn in this. So by all means, if you come up with some ideas or things that you want to run by our team here, the folks that you've seen from Virginia Tech on this call enter a national competition. When is your competition, Jackson? When it's later this spring?
I think Sean would know that better than I would.
Sean.
Sean gone? Okay, Sean's gone. Never mind. So correct me if I'm wrong. I think it's end of May after finals.
Yeah, that sounds about right. Assuming that we make it to the next round of testing, or not testing, sorry, the competition.
I think we will. I got to text you about that one actually. I think I met someone also on like New Hampshire University, and it was like 7 people.
Yeah.
Yeah. And just throwing this out here, I typically have a class until 7:30. So I'm not always gonna be able to make the meetings. If you guys have blade related questions or any sort of arrow questions, if you can reach out to me certainly, and I can answer them outside, or I'll try and join at 7:35. Or if you have questions now, even I can answer those. So just throwing that out there.
Well, and Ebad, you have a question, is there a group chat where I can receive help and brainstorm with others? That's in essence what Maker Mondays will be. This being the first meeting, we're just into a general conversation. But in future Maker Mondays, what we do is we break into breakout rooms. And similar to what Quinn just said, if you want to trade some ideas on blades, we will have a blades breakout group. If you want to have something more related to the wiring, we'll have a different breakout group for that. So that's what this is a weekly chance to trade ideas with it. Colin, your question on when the resistors arrive, we are ordering the new ones this week and we'll be shipping them out. They'll come in a small envelope, given the size of these. I think realistically, probably sometime next week is when you would get them. That's going to be probably the quickest we'll get everything here and then shipped back out to you. But again, we'll get those to you. I do see the question on how much these motors are rated for. That is a question I can look up for an answer for you on that. I am not sure myself. Do we have other questions? Okay, we are at 7:48. If there are no other questions, we will wrap up early tonight. You can see Jackson has posted in there a link to resistors. And actually, I think that's the same place we got ours from, Jackson, if I'm not mistaken.
Actually, I just DM'd it to you. I can put it to everyone else as well.
Yeah, but you can see there. You're certainly able to use any parts that you come up with to build this. Our goal is to give you the basics and have them accessible to everyone. So we ship these out as something that hopefully is useful to you. But certainly this is about your creativity. That's what this is about. So as you come up with different ideas, do run with those and other parts that you can use. You're more than welcome to. The question is, what does the generator look like? Because I don't know if I have one. It looks like this. You'll see some wires attached to it. I want to disconnect it from the alligator clip, but that's what we have here. And again, in the case that Remy showed, this is something you could potentially fit into a PVC pipe like that. And again, something that could spin. Question is, what type of resistors do you want us to use? Not sure if I'm going to answer this correctly for you, but 30 ohm resistors is what we're providing. But as you saw some of the discussion tonight, there's other ways that you can go about matching that. I don't know that there is any type of expectation on what you use. I will say that one of the things you may want to do, and I'll post this in the chat before we go, the KidWin competition does have a website. And I'll also, given some of the questions we have, get into some of the rules of it. We'll have that be a topic for one of our upcoming chats. We'll have someone to go over those rules, just so we're clear on those. You can see in the link that I'm putting in the chat here, there's a rules and rubrics page that I'm going to post a link to. That is right here in the chat. And that can give you some of those rules as well. Again, just to clarify, KidWin competition is separate from us here at Virginia Tech. We're simply, helping you. Colin, I see the, excuse me, I'm about to sneeze. Speaking of wind competitions, so the resistor placement, if you have your generator here, On the other hand, you're going to have two leads. I'll call your positive and negatives. And then you're basically bridging, and Quinn or Jackson, correct me if I'm off base here, because you know more than me in this, but basically you're bridging these two leads, and to hold that bridging, you're using alligator clips that are going to do that. So you'll find an alligator clip, and mine are currently tangled, but for demonstration purposes, does not necessarily matter the color as long as you're consistent with what you're doing. But what you'll see here is that using and connecting the metal of these together, you're connecting that and that with another, the other side of the alligator clip. And again, you want to make sure you're making a good connection, which again, as I said, you need some kind of decent motor skills with. Mine's come loose there. Jackson, Quinn, is that correct how I'm showing here? Yep. So Colin, hopefully that helps. I'll try to get up, maybe be able to get a document camera for the next time, just so we have something that's a little easier to show than my normal camera here. How do we attach the generator to the restrictor? Is this what you're referring to, Niam? The restrictor. You mean the resistor? That's what I was showing just now, the how the resistor connects in. So again, you're using the alligator clips right here, bridging the two. So you're connecting your leads here, and then bridging these, you have your resistor. Do we have other questions? Where would we put it if we got the PVC pipes? I think that's really part of your design process. You're going to have to be creative. Potentially, as Remy showed, you may use electrical tape. That's the black kind of stretchy rubbery tape that you use. Using whatever tower you create, how you do your wiring may require you to be creative in how you mount everything on it. You can use different methods to do that. Certainly, you would want something that's going to be stable, so that when you're handling the forces of wind and everything, that what you hook up will stay put. But that's up to you really on how you where you put it if you are using the PVC pipes. So again, just to recap, we have about on the end of our time here. Same time, same Zoom link every week. We will be on here. You will see some different faces from tech from time to time. As Quinn mentioned, our students who join us, we have classes, and yes, even classes that go to 7:30 at night. Understand that we may see some different faces in here. What we do in our office is connect our engineering students to this call, so you may see some new faces on here. But 7 p.m., we will treat this as a brainstorming idea. What will generally happen is we'll have a different topic of discussion each night. It may be the rules of the competition. It may need to be some concepts behind blades or behind the generator itself. But what we will do is do that, and then we will go into some breakout rooms where you can talk about what you're building. And we can certainly help you troubleshoot any problems, questions you have. I'll once again put in the chat here, if you need more supplies, from what's in here, let me know about pathways at vt.edu. Do know that I'll be shipping out new resistors as they come into us. Again, all apologies. When we opened the package, which had a hole in it, we realized we were short quite a bit of what we had ordered. So we decided to go ahead and send without them noting who did not get them. And so we'll get those to you. The link I showed previously on the competition, I encourage you to check that out because that will certainly answer some questions there as far as the competition itself. We want to thank you. This is a great conversation. And to those of you who are joining us, and I hope our college students who have joined us tonight will agree with me on this, what you all are doing is the same conversations that happen at the college level. So, you should really be proud of yourself to think about the technical aspects of generating power. Conversations like gearboxes and things like that are certainly part of the conversation, and even creative ideas on using a car generator or things like that. Certainly, I will guarantee you that some of these conversations on generating power, whether it's cars of the future, whether it's part of our electric grid, these are conversations that engineers are having all the time. So you're certainly on the right course of considering how you can create more power. And so that's what this competition is about, to get us thinking outside the box, if you will. We are at our time. And so at the risk of us getting way off course on what motors and generators we can use, I'm going to go ahead and end our call for tonight. Again, we always end by 8 o'clock. Jackson, I see you got a resistor there. Is that what you have?
Yes, to answer your question, I actually have a burned resistor. So your resistor will burn. This, I don't know if you can tell, but it's like black. It will probably burn a resistor. I think actually you can probably do it with your motor actually if you use a 1 watt. So be careful.
Yes. Yeah. And certainly if you have any questions about the safety of what you're doing, do talk. Feel free. We will get you answers on it. Certainly we're doing things that we want to learn from, we want to stay safe with. So again, as I said, when I go home tonight to fix my furnace, it will be unplugged and I'll be working on it because I understood capacitors have some stored energy in them. So I have to be a little bit careful with how I handle it and everything. So again, safety matters first and foremost. We are at 7:59. We're going to go ahead and close it out for tonight. Want to thank our VT Wind Turbine team. Some of those had to leave early, but Jackson and Quinn, thank you all for joining us. To all those who asked questions tonight, thank you again. We will see you next Monday, 7 o'clock, same channel, same place, and we'll see where we're at. Good night, everyone. Take care. Thank you all.